Okay, 3.1 deals with derivatives, which probably is like the biggest thing in calculus. We got three definitions here. Two of them we already know. The first one is new though. So a derivative is going to be the equation for the slope of the tangent line to a function at any given point. So up until this point, we've been just finding tangent lines at a given point. The derivative is going to allow us to find the equation for the slope at any point, not just one of them. These next two definitions, tangent line, normal line, we already talked about in section 2.4, so they should be familiar to you. Derivative function, this formula should look extremely familiar to you. Formula should. Derivative function f with respect to the variable x is the function f prime. So we're going to look at notations here in a second, but if you see an apostrophe, dead giveaway, we're taking a derivative. Our formula for that is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. The only difference between this formula and the one we used in section 2.4 is that x is going to stay x in here. We're not plugging in numbers, it stays a variable. I also want you to note that we could easily rewrite this, if it helps you, as 1 over h multiplied by f of x plus h minus f of x. Since some of these problems get messy with fractions and everything, it may be beneficial to pull that 1 over h out front like that. We do have an alternate definition. It doesn't pop up often, but it will every few years or so on the AP exam during multiple choice. We say f prime of x equals the limit as x goes to a of f of x minus f of a over x minus a. Key here is if you see anything like this, to realize that they are asking you to find the derivative and then be able to do that. We're going to look at many different ways to find derivatives. You're not always going to have to plug into this formula up here. These are all common notations for a derivative. You need to be familiar with them. Again, apostrophe, that is y prime. Apostrophe, dead giveaway, we're taking a derivative. We have dy dx, so think of the d as the derivative of y with respect to x. Df dx, d dx, f prime of x, or just flat out f prime. Any single one of these tells you that you're taking a derivative or that you are dealing with a derivative function. And we need to know that. All right, so jumping into examples. And again, we're going the long route on these for another couple days or so. Example 1, they ask us to differentiate f of x equals x over x minus 1. So with this, they're asking us to find the derivative. So I'm going to go f prime of x is equal to, and I'm going to throw my generic formula in there. It's going to be the limit as x goes to 0 of f of x plus h minus f of x all over h. Just like we did before, it may be beneficial to find this f of x plus h and f of x before, like when we lay the foundation. Or we could just plug in. For today, I'm just going to plow through this. So we're going to have limit as x goes to 0, not x, should be an h on these, as h goes to 0. And I need to plug x plus h into the function. So wherever I see an x, I'm plugging in x plus h. It gives me x plus h over x plus h minus 1. Okay, so we got that for the first one. Minus f of x, so I just rewrite the function. And that is all over h. Okay, just like we did in section 2.4, I need to take care of this top part first, and they give us fractions here, and we are subtracting them. So we know that we need to get common denominators. Remember, this is all like one part. So this x plus h minus 1 is one thing. This x minus 1 is one thing. So to get our common denominator, the first one, I'm multiplying top and bottom by x minus 1. Second one, I'm multiplying both top and bottom by x plus h minus 1. All right, from here, multiplying out. Numerator, if I go ahead and FOIL that out, we are going to be left with x squared plus xh minus x minus h. Denominator, I'm not going to bother multiplying out. I'm just going to leave it x minus 1 and x plus h minus 1. Second one, I got minus. Distributing that x in, it's going to give me an x squared plus xh minus x. Denominator, again, I'm not going to bother multiplying out. Since this is getting pretty messy here, instead of putting the over h down below, I'm just going to write it that I'm multiplying this whole mess by 1 over h. Remember, multiplying by 1 over h is the same as dividing the whole thing by h. Okay, from here we have common denominators, so we can go ahead and do the subtraction. I'm going to try to clean it up a little bit. I got an x squared minus x squared. It's going to go away. I have an x plus h minus an x plus h. It's going to go away. I got a negative x minus a negative x. Remember, minus a negative becomes plus a positive. So negative x plus x goes away. And I am just left with negative h up top. So we have the limit is h goes to 0 of negative h over x minus 1, x plus h minus 1. We are multiplying all of that by 1 over h. From there, multiplying all that by 1 over h, the h is reduced out, and we get a final, not a final answer, but our limit simplified down to be negative 1 over x minus 1, x plus h minus 1. At this point, we can go ahead and plug 0 in for h. When we do so, this 0 is the only one that goes away. So we are left with our derivative being f prime of x equals negative 1 over x minus 1 squared. The reason the x minus 1 is squared is because the factor shows up twice. I got an x minus 1, x minus 1. Okay, so that's our derivative right there. From there, we're asked to find a couple different things. For B, they want the equation for the tangent line at x equals 3. In order to find the tangent line, we need two things. We need a slope. Slope goes with derivative. So m equals f prime of x, which is negative 1 over x minus 1 squared. If I'm doing it at x equals 3, we need f prime of 3. Plugging that in, 3 minus 1 is 2, 2 squared is 4. We get a slope of negative 1/4. The other thing we need is a point. So for my point, my x value is 3. We need to find the y value. To find the y value, you go all the way back to the original function. So f of x equals x over x minus 1. We go ahead and plug in 3, so f of 3 is going to give me 3 halves. So our y value would be 3 halves on that. Finishing up, we can do it in point slope form. It's going to be y minus 3 halves equals our slope negative 1/4 x minus 3. So that's the equation of our tangent line. C, they want us to find f prime of 2. So we go back to our derivative function. F prime of 2 is going to equal negative 1 over 2 minus 1 squared. It's going to give me a negative 1. I want to know, what does this mean? Okay, the apostrophe derivative tells us slope. So it tells us that the slope of the tangent line at x equals 2 is negative 1. Okay, so whenever you have the derivative, we're thinking slope right away. Slope is negative 1 when x equals 2 for my tangent line. D, where does f of x have a slope of negative 4? Thinking about that, go back to your derivative because we're dealing with slope. Want to know where does it have a slope of negative 4? I'm plugging that in as my derivative. So negative 4 equals negative 1 over x minus 1 squared. From there, and with this, I actually want to switch this for this example anyways. We're not going to deal with negative 4. We're going to deal with negative 1 with this, because I believe that's what it is in your notes. So we're going to go negative 1. We go ahead and multiply it up. We got negative x minus 1 squared equals a negative 1. Divide the negative 1 out. Go ahead and solve by square roots. Remember when you solve by square rooting, you need both a plus and a minus. So I'll get x minus 1 equals a positive 1. X minus 1 equals a negative 1. Solving it, it's going to occur at x equals 2 and x equals 0. All right, so that's it for example 1. Example 2. Because y equals square root of x. They want us to go ahead and find the derivative. We know first derivative equals the limit is h goes to 0 of f of x plus h minus f of x all over h. Substituting in, we get the limit is h goes to 0 square root x plus h minus square root x all over h. Okay, with that, you go ahead and try to plug in 0. Can't plug in 0 because it makes the denominator go to 0. So we got to do some algebra. With the square roots, we've already done this multiple times. We are going to multiply by the conjugate. Numerator and denominator. So our numerator, when we go ahead and FOIL this out, we are going to be left with the limit as h goes to 0 of x plus h. My out and in are opposites, so they reduce out. And then I have a negative square root x times a positive square root x, leaves me with negative x. Denominator, like I've been saying, we're not going to multiply that out. Reason being, we want stuff to reduce out. So if I were to multiply it, I would just have to factor it out in my next step. At this point, x is reduced out. And then I have an h in the numerator, h in the denominator. Those reduce out. Leaving with the limit is h goes to 0 of 1 over square root x plus h plus square root x. At this point, you can go ahead and plug 0 in for h. Denominator doesn't zero out. And when we do that, we're going to be left with f prime of x equals 1 over square root x plus square root x, which is the same as 1 over 2 square roots of x. Don't have to worry about rationalizing that denominator. You can go ahead and leave it alone. If they want you to rationalize, they will tell you. Most likely in this class, you won't have to ever. Okay, B, find f prime of 4. So you f prime of x is 1 over 2 square roots of x. F prime of 4 equals 1 over 2 square roots of 4. We go ahead and work it out, and we're going to get 1/4. What does that mean? It means the slope of the tangent line at x equals 4 is 1/4. Done. C, find the equation for the tangent line to the curve. We need our slope. We went ahead and found the slope in part B, so m is going to be 1/4. And then we need a point. For my point, x value is 4. we need to go back to the original function. So f of 4. F of x originally was just the square root of x. So f of 4 will be the square root of 4, which is 2. Given me equation of y minus 2 equals 1/4 x minus 4. All right, with this, the last thing they want is the normal equation. From 2/4, we know that the normal equation is going to be the same exact equation as the tangent, only difference, slope is opposite, reciprocal. And that is that.